There's a reason Wisconsin feels different from the rest of the country. An invisible line changed its fate forever. Once you see what divided it, you can't unsee it. Wisconsin looks simple when seen on a map. Forests spread across the north, farmland fills the south, and lakes seem to appear everywhere. At first glance, it feels like a typical Midwestern state, the kind of place shaped by gentle hills and quiet rivers. But once you begin traveling across Wisconsin, something strange becomes noticeable. The landscape suddenly changes in ways that do not feel gradual. Instead, the terrain shifts almost abruptly, as if someone drew a hidden line through the state and gave each side a completely different identity. Geologists eventually realized that this strange contrast is real. Wisconsin is divided by a geological boundary created thousands of years ago during the Ice Age. On one side of that boundary, glaciers completely rebuilt the land. They flattened hills, carved basins, and left behind a patchwork of lakes and wetlands. On the other side, something unusual happened. The glaciers simply never arrived. The terrain stayed exactly where it had been for millions of years, continuing to evolve without interruption. The difference between those two regions is dramatic. In the north and east, the landscape feels young and water-filled. Lakes appear in nearly every direction, and the land rises and falls in rounded shapes that were molded by ice. Travel southwest and everything changes. Instead of soft hills and scattered lakes, deep valleys cut through rock layers. Steep bluffs rise above winding rivers, and the terrain suddenly looks far older. Most people never notice the invisible boundary that separates these two worlds. Yet that line explains why Wisconsin looks and feels different from most American states. It also explains why certain towns exist where they do, why certain areas stayed wild, and why the land itself seems to tell two completely different stories, depending on where someone stands. Understanding that invisible divide begins with the region that escaped the glaciers completely. Southwest Wisconsin contains one of the most unusual geological regions in North America. This area is called the driftless area, and the name comes from something surprisingly simple. Most land that glaciers once covered contains drift, which is the mixture of rocks, sand, gravel, and soil left behind as ice melts. In this part of Wisconsin, that drift does not exist. For a long time, scientists wondered why. During the last ice age, massive glaciers advanced across much of the northern United States. They buried entire regions under thick layers of ice and slowly reshaped the ground beneath them. When those glaciers retreated, they left clear evidence everywhere they had been. But in southwest Wisconsin, the land looked untouched. Instead of smooth hills and scattered debris, the driftless area displays a rugged landscape carved by rivers that have been flowing for millions of years. Tall limestone bluffs tower above narrow valleys, and winding waterways twist through steep ridges. The terrain feels older, more dramatic, and far less predictable than the glacial regions nearby. Counties like Vernon and Richland show this contrast clearly. Travelers driving through those areas quickly notice how the land rises and falls in sharp ridges rather than gentle slopes. Valleys known locally as coulees cut deeply into the hillsides, forming long corridors where rivers flow between towering rock walls. These valleys did not form recently. They developed slowly over enormous periods of time as rivers carved deeper and deeper into layers of limestone and sandstone. When geologists drill into the ground here, they uncover ancient soils and river sediments that have remained in place for an incredibly long time. What they do not find are the glacial deposits that appear almost everywhere else in Wisconsin. The evidence is clear. The glaciers simply never crossed into this region. That absence allowed the driftless area to preserve a landscape that existed long before the Ice Age began. While the rest of the Midwest was repeatedly scraped clean by ice sheets, this corner of Wisconsin continued evolving naturally. Rivers kept carving valleys, slopes kept eroding slowly, and the terrain gradually became more dramatic. Standing on a bluff overlooking one of those valleys feels like looking into a different chapter of geological history. The surface of the driftless area tells one story, but the underground landscape tells another equally fascinating one. Much of southwest Wisconsin rests on limestone bedrock, which reacts slowly when exposed to water. Rainwater absorbs small amounts of carbon dioxide from the air and soil, turning slightly acidic. When that water seeps into cracks in limestone, it begins dissolving the rock over time. That process happens gradually, but over thousands and millions of years, it creates a remarkable underground system. Caverns open beneath the hills, sinkholes appear where the ground collapses into hidden voids, and water begins traveling through underground channels before reappearing somewhere else. Many of the region's streams begin as springs emerging from these underground systems. The water rises from deep within the rock layers and flows into clear, cold creeks that wind through the valleys. Because the water travels underground before surfacing, it remains cool throughout the year. These cold streams create perfect environments for trout. Anglers often visit the driftless area because the water conditions remain stable even during hot summers. The springs feed the rivers continuously, creating a network of waterways that stay lively year-round. The underground structure also explains why the rivers in this region twist and turn so dramatically. They follow paths carved long before the Ice Age, tracing ancient channels that were never erased by glaciers. Instead of straight or recently formed rivers, these waterways wander through the hills in patterns shaped by millions of years of erosion. The land above and below the surface reflects a continuity that is rare in the Midwest. It is a landscape that never had to start over. Travel north or east across Wisconsin, and the terrain begins to transform. The steep valleys fade away and the ground becomes gentler. Lakes begin appearing in every direction, some large enough to feel like inland seas and others small enough to fit within a single forest clearing. This part of Wisconsin tells a very different geological story. During the last ice age, enormous glaciers spread across this region, covering the land under thick sheets of ice. As the glaciers advanced, they scraped away older terrain and carried massive amounts of rock and sediment with them. When the climate eventually warmed and the glaciers retreated, they left behind an entirely new landscape. Instead of the ancient river valleys preserved in the driftless area, glaciated Wisconsin became a patchwork of basins, ridges, wetlands, and rolling hills. One of the most recognizable features left behind by glaciers is the Kettle Lake. These lakes formed when large blocks of ice broke away from the main glacier and became buried in sediment. Over time, those isolated ice blocks slowly melted underground. When they finally disappeared, the ground above collapsed into deep depressions. Rainwater and melting snow filled those depressions, forming thousands of kettle lakes scattered across northern Wisconsin. The glaciers also created ridges known as moraines. These ridges formed at the edges of the ice sheets, where debris accumulated as the glaciers paused during their retreat. Moraines now stretch across the landscape in long arcs that mark the positions where glaciers once stood. Between those ridges lie drumlins, smooth, elongated hills shaped by the movement of ice. Each drumlin points in the direction the glacier once flowed, like arrows left behind in the terrain. Together, these features created a surface that holds water easily. Low areas collect rain and snowmelt, forming wetlands and ponds. Streams often struggle to find clear routes because ridges and debris block easy drainage. This is why northern Wisconsin contains so many lakes and marshes. The landscape itself was designed by ice to trap water. Long before highways and railroads, Wisconsin's rivers acted as natural travel routes. Waterways allowed people to move across large distances through forests and wetlands that were otherwise difficult to cross. One of the most important routes followed the Fox River toward Green Bay and Lake Michigan. Not far away, the Wisconsin River flowed in the opposite direction toward the Mississippi River. Near the town of Portage, the two rivers approach each other closely, separated by only a short stretch of land. For centuries, indigenous travelers used this natural connection. Canoes could move along one river and then be carried across the short land passage to the other waterway. This small link created a transportation corridor connecting the Great Lakes to the Mississippi River system. Fur traders later followed the same path. The route became a vital channel for commerce as goods moved between distant regions. In the 19th century, engineers believed they could transform this natural corridor into a major shipping route. By building locks, dams, and a canal near Portage, boats could theoretically travel from Lake Michigan all the way to the Gulf of Mexico. The idea promised to place Wisconsin at the center of a powerful trade network. However, the landscape soon revealed its challenges. The lower Fox River drops nearly 170 feet over a relatively short distance, forcing engineers to build multiple locks and dams to control the water levels. Upstream, the rivers flowed through sandy glacial plains, where shifting sandbars constantly changed the channels. Keeping the waterways navigable required constant maintenance. Sediment filled the channels, floods damaged structures, and low water levels sometimes stranded boats entirely. Before continuing deeper into Wisconsin's story, take a moment to subscribe to the channel if you enjoy uncovering hidden histories behind landscapes and places most people overlook. By the time the final locks were finished, railroads had already become the dominant form of transportation. Trains moved faster, required less maintenance, and were not affected by water levels or shifting riverbeds. The canal dream slowly faded, leaving behind a chain of quiet locks that still hint at the ambitious vision that once existed. Another dramatic chapter in Wisconsin's geological story unfolded near the end of the Ice Age. As glaciers melted, enormous volumes of water spread across the region. In central Wisconsin, that meltwater gathered behind a natural barrier of ice and debris near the Baraboo Hills. The water eventually formed a massive inland lake known as Glacial Lake, Wisconsin. The lake stretched across thousands of square kilometers, covering a huge portion of the state. In many places, the water reached depths of 30 to 50 meters. For a long time, the lake remained stable behind its fragile dam, but that barrier consisted mainly of ice and loose sediment, which meant it could not hold forever. Eventually, the dam failed. When it collapsed, the lake released an enormous flood that surged across the landscape. The rushing water blasted through soft sandstone layers and carved a narrow gorge that is now known as the Wisconsin Dells. The flood carved steep cliffs, towering rock formations, and narrow channels in a remarkably short period of time. What appears today as a calm, scenic gorge was created during a moment of extraordinary geological power. After the water drained away, the exposed lake bed became what is now called the Central Sand Plain. The floodwaters stripped away much of the previous soil, leaving behind wide stretches of sandy terrain. Today, that region supports farms, wetlands, and patches of forest, but the sand beneath the surface still reveals the story of the ancient lake that once covered the land. While glaciers reshaped much of Wisconsin, certain rock formations proved too strong to erase. One of the most important examples is the Baraboo Hills, a range formed from extremely durable quartzite. Quartzite is one of the toughest natural rocks on Earth. When glaciers encountered the Baraboo Hills, they could not easily grind the ridges down. Instead, the ice flowed around them, splitting into separate paths as it moved past the obstacle. These hills are incredibly old, dating back more than 1.6 billion years. Their survival through multiple geological eras allowed them to influence how glaciers moved across the region. Another major rock feature shaping Wisconsin is the Niagara Escarpment. This long ridge of limestone and dolomite runs along the Door Peninsula and extends into other parts of the Great Lakes region. The escarpment influenced both glacial movement and modern shorelines. It helped determine where lakes formed and where coastlines developed. These ancient rock formations act like anchors in the landscape. Even powerful glaciers had to adapt around them. Wisconsin's geological history also connects to one of the oldest traditions of metalworking in North America. More than 1 billion years ago, a massive rift opened deep within the continent, flooding the region with volcanic rock and leaving behind deposits of nearly pure copper. Thousands of years later, indigenous communities discovered copper nuggets scattered across the land. By around 6000 BCE, people in the region began shaping the metal into tools, spear points, and decorative objects. These copper items traveled far beyond Wisconsin through trade networks that connected communities across large portions of the continent. Artifacts made from Great Lakes copper have been discovered hundreds of miles away in distant river valleys. The land itself helped create those connections. Rivers, lakes, and natural travel routes allowed goods to move across enormous distances long before modern transportation existed. Wisconsin was part of a continent-wide exchange system thousands of years before industrial mining began. The next time someone looks at a map of Wisconsin, that invisible line may still be impossible to see. But once the story behind it becomes clear, the entire state begins to look different, and the real question becomes impossible to ignore. If one hidden boundary can reshape an entire state, how many other landscapes across the world are quietly divided by stories most people never notice?